Welcome back, my fellow colleagues. This is 268 missing number. First time doing this problem, by the way. Actually true. Not gonna lie, I'm feeling like kind of a five-head right now. But 268 missing number given an array of nums containing n distinct numbers in the range 0 through n inclusive. That's what these square brackets right here mean. Return the only number in the range that is missing from the array. Follow up, can you implement a solution using constant, space, and linear time? So input nums is 3, 0, 1. The range here is 0 to 3 inclusive, so that would be 0, 1, 2, 3. The correct answer here is 2 because 2 is missing from the array. Same thing here. The range is 0 through 2, and you can tell because the amount of numbers in the array is what the range is the end of the range. So there's 2 numbers in the array, so the range should be 0, 2 square brackets. So the range there is 0, 1, 2, but 2 is missing, right? So the output here should be 2. 2 is missing. Same thing here. There's 9 numbers in the array, so the range should be 0 through 9 inclusive. If you read through here, 8 is the number that's missing, so on and so forth. The last one being there's 1 item in the array, so the range should be 0 through 1 inclusive. That means we should have 2 numbers in the array, 0 and 1. 1 is not here, so that's the problem there. There's a few different ways to do this one. So the first one, what we can do is, some of you clever, I'm going to show you 3 different ways to do this. Okay, so the first way is going to be iteration, dictionary, Gauss. So the first way to do it, right? So you have this list of numbers that you have to check through, right? So the first way you could check whether or not a number is missing, right, is, and it's great. This solution works great because they said that the missing numbers are inclusive with 0, and what starts at 0 and goes through a number at the end, a loop, right? So what you can literally do in this one is you can just do for index in range of the length of nums. You can just check if index does not equal the number at the index, then we'll return the index, right? But this will only work, right, because, well, the first thing we have to do before we can get this to work, if you think about this, let's just imagine this as the numbers that are generated from the array when you loop through an array, and let's just say this is the list of numbers that they give us, right? The problem here, right, is that this list is not assumed to be in order, right? So if we go through the first iteration, 0 is not equal to 2, we're going to return index 0, right? Index 0 is not missing in the list, it's just at the end. So the first thing we have to do is we're going to have to sort this, right? So we're going to do nums equal sorted nums, right? And then this should be fine. That way we can iterate through and be like, wait, 1 does not equal 2. The number that's missing in this interval is 1, and then we'll return the index here. But this works fine if we're only checking the entire contents, pretty much everything in the middle, right? If you have a scenario like the one they mentioned here, right? So if we do 0, 1, 0 and 1 here, right? And the input they gave us, right, is 0 and 1. Now, if you go through this, right, this will be iteration. And this will be nums, right? And if you go through this, you'll be like, oh, these are basically the same, right? But the number's missing. The number that is missing is 2. That is true because our loop goes from index, which is 0, to range of length of nums, which is 2, 0, 1, 2, not including the last one, right? So the thing we have to note, if we make it through this list without returning, then that means the missing number must be at the end, right? Because the missing number here is 2, right? So the thing that we can do, we know that we can always get the missing number that's at the end. If we get through this, we can do return length of nums, right? Because we said the range would always be the length of the list, 0, set it up here, 0 through the length of the list containing n distinct numbers. So 0 through 3 numbers here. The range here is 0 through 3 inclusive. So if we run this, oh boy, I forgot to comment this nonsense out. And we didn't even indent any of this. Oof. Oh my god, a lot of A lot of small typos. So this gets through. This is fine. First time doing this problem, by the way. What's the time and space complexity, right? Well, it takes linear time to iterate through the array and check whether or not the numbers are equal, right? First, we have to sort it. And the worst case performance for this sort here, which is probably going to be quicksort, is going to be n log n. So in terms of n log n versus versus linear time, which is just n, this algorithm is going to be bounded by the sorting, which is n log n. So space time complexity here is going to be n log n. Space complexity here, it might as well just be constant time, because it really depends. Actually, if you can't sort this in place, then you have to allocate space to do that. So we could take linear space, but whatever sorting algorithm is used under the hood here, I don't know. So we're just going to assume it's constant time with like a in-place quicksort or something like that. But so that's what you get there, right? So that's the first way to do it. The second way to do it is with the dictionary, right? Now with the dictionary method, we can kind of cut out the sorting, right? Because we can just look up. Because we're only iterating, so we can kind of check the index equals the value in nums, right? But with the dictionary, we can just look it up. So we can just create num dict is going to be equal to default dict, right? And the idea here is we're going to iterate through the list, create a dictionary, and the dictionary works perfect here because the question says that containing n distinct numbers, so there's not going to be any duplicates here. So we can iterate through just the range of numbers after we create the dictionary, and if we try to look up a number and it's not in the dictionary, then that's the number that's missing from the list. So num dict equals default dict, right? Then we're going to say for num in nums, if we're just creating it here. So we're just going to say num dict sub num equals 1, right? And so we kind of make it there, and then we can do this again, but we're gonna iterate through index wise like we did last time. So for an index in range, and we're just gonna do length of nums plus. Now we're just gonna do for index in range length of nums. And so what we can do here is we can just say, might be a caveat here. We're gonna say if num, or if index, because we're just going to get, like we said before, we're iterating 0, 1, 2 to the length of the list, right? And then we have nums, right? So we just have to say, if index not in num sub dict, return index. And I think we might have to do one more thing to check, kind of like with the end of this. If we make it through here, let's just see. Invalid syntax, I forgot a colon. Yeah, okay, perfect. So this is the same thing that we had before, right? We have 0, 1. If it's not in here, right, then we have to return the length of the array. So this is pretty dope. This one's pretty fast, but it really depends on how many people on the server. So like we said, there's no sorting here. It takes linear time, right, to go through the array and create the dictionary, right? So, and then it takes linear time to iterate through the dictionary, probably less than linear time, right? Because we'll probably find the number that's missing before then, but worst case, it's going to be linear time. So the time complexity here is actually going to be linear time. The space complexity here, though, it's going to be linear space, right? Because we have to, our dictionary is going to, linearly scale with the size of the list that's input into this function. So there's nothing much we can do about that. But the final way you can do it, right? Could you implement a solution using constant space and O of n runtime complexity, or linear time complexity, right? You might be thinking, how can we do that? So my more mathematically inclined brothers and sisters will remember that there's a kind of a sneaky little thing we can do here. So we have a range, right? 0 through n, right? And so if we think about this, if we have 0 through n and we have n distinct integers, with the way addition and subtraction works, couldn't we just sum all these values up, right? So let's just say we're doing the range 0 through 3. And we'll just say, okay, 0 plus 1 plus 2 plus 3, right? This equals 3, right? And let's just say that's the, the list we're given, or what the answer should be, right, given the length of the list. But the list that they give us, it doesn't matter if it's sorted or not, they give us, boom, right? So obviously the number missing here is 3. Oh my gosh, that equals 3. This equals 6. Kind of have a 3-head moment. But if we sum this, right, we'll get 0, 1, 2 equals, 0 plus 1 plus 2 equals 3, right? And it's crazy because if you think about it, if you subtract the summation of the length of the array, right? Because we have 3 numbers, and if you do this summation, you'll get what the total numbers in the list should add up to, right? You get 6. And if you do it with the list that's missing a distinct number, you get 3. And if you subtract these, you actually get the number that's missing, right? 6 minus 3 equals 3. 3 is the number that's missing, right? So how do we do that, right? And I'll do it the slow way first, then we can do the optimization. So we'll say the correct sum, right, is going to start at 0. And then what we're going to do is we're going to say for num, we're going to do for index in range of length of nums. And I think we might have to plus 1 here just to include the last value. What we're going to do is we're going to do correct. It's probably a one-line way to do this in Python, but we're skipping all the extra garbage. Plus equal index. And so this is going to create a linear summation of all the values from 0 to the length of the list inclusive, right? Because if we do 0 through 3, iterating through list kind of works exclusively, or inclusive of the beginning, exclusive of the end. So you get 0, 1, 2, right? Well, we want to do 0, 1, 2, and 3. That's how we're doing plus 1 here. And so what you'll get, let me comment this stuff out, is the correct sum. The list should summate to whatever correct sum evaluates to here, right? And so the second thing we can do, right, we can actually do for num in nums, and this will be exactly like we did. Remember, we're subtracting here to get the value that, so we're going to get 6 here, right? So now we have to go through the list they gave us and subtract all the values in there. And if it doesn't equal 0, which it won't if we're missing a number, then we'll just return what's left. So for num in nums, correct sum minus equal num. And then what we'll do, we'll always find out that the value that's remaining is correct sum. And this might not make a lot of sense, but makes a lot of sense if you understand summations. So 0 plus 1 plus 2 plus 3 equals 6. This is what the list should equate to, right? Should equate to if no missing numbers. So if there's no missing numbers, we should get 6. Now if we're missing numbers, we're going to end up with some value. In this case, it's 3 because we're missing the last value, but let's just change it up here. We'll just say the number is this. So now our list, when we add up, evaluates to 5. So if we have the correct sum of what it should be, and then we subtract all the numbers that we actually have in the list, what we end up with is the difference between the lists. And the difference between the lists is the number that's missing. So it takes linear time to calculate the correct sum, and then we have to subtract all the numbers in the list that they give us to get the value that's missing. That will add up to create the correct sum. So those of you who remember a little bit from math will know that the function or the formula to summate a value without literally going through and doing this is equal to n times n plus 1 over 2. So this is just a formula you can use to linearly summate a value. And so what we can do is just replace correct sum, so that entire thing that's just going to summate that value with and just to I don't know if len, the function that calculates the length of a list, is constant time or not. So we're just going to assign it there, and we're going to do exactly like the function above said, numlen times numlen plus 1 over 2, and then we're just going to wrap this in parentheses to make sure everything lines up correctly. And then what we'll still have to do is we'll still have to subtract these values, right? But this will just kind of save us the first for loop. And so what we can do is we can just run this again, and you'll see int object is not callable. Not exactly sure what's at. Line 13, correct sum is equal to, maybe I messed up something here. Oh, I forgot to add this. Boom. Oh yeah, and of course we divide, so we're going to get a float as a return, or pretty much anything, not a whole number. So return this, and you'll see that the time's really going to vary. We just ran it a few times, we get different different times, based on how people are running code on the server. But this is going to be done in constant space, because this is pretty much happening. We just have to make two variables here, and so our variables aren't going to scale with the size of the input, but it's going to be done in linear time because we have to linearly iterate through the list that they give us to subtract it from the correct value of the summation of the list. And so that is 268 missing number.